Welcome to Module 14 on the quadratic formula. Right now, pause the video, find your notebook, get that out. Make sure you're taking notes where I ask you to take notes. Note taking is important so that you have access to what you're learning without having to rewatch the videos. Plus, you can use your notes on the quizzes. Today, we're going to learn about Module 14, the quadratic formula. So you're going to want to find a new page in your notebook and write at the top of that page, Module 14, quadratic formula. We're going to talk about applying the quadratic formula where you get exact answers, like when the square root of 4 is either 2 or -2. We're going to talk about applying the quadratic formula when you get decimal answers, like square root of 5, we would have to estimate. And we're going to define the discriminant, and I'm going to tell you how to use it. So why does the quadratic formula exist? Not every equation can be solved by factoring. If I'm trying to solve this using factoring, I need to do 3 times -5, which is a times c. I'm looking for two numbers that multiply to be a times c and add to be b. 1 and 15 aren't going to work. 3 and 5 aren't going to work. And there aren't any other factors of 15. This one is not factorable. That doesn't mean that I can't solve it, though. What that means is I need to use the quadratic formula. So I want you to write a new topic, and I want you to pause the video, and I want you to take a minute and actually write down these formulas. You need the quadratic formula in your notebook, and you need the standard form of an equation in your notebook. Go ahead and pause the video and do that now. All right, once you have that done, we'll talk it through. The quadratic formula can be used to solve any quadratic equation, but is particularly useful for ones that cannot be factored. So when we discovered that this was not factorable, it doesn't mean it's not solvable. It means I need to substitute into the quadratic formula after I check to make sure it's in standard form. So you're going to want to have your quadratic formula handy where you can see it. I'm not going to rewrite it every time, but I will this first time. It's -b plus or minus the square root of b squared plus -4 times a times c all over 2 times a. This is already in standard form. I've got the number with the x squared, an invisible one with the x, a constant by itself, and it's equal to 0. A is 2, b is 1, and c is -9. So now we're ready to substitute in. You want to be careful about b. The formula asks you to use -b for this. So b is 1. I'm going to substitute in -1 because there's a -1 in front of the b. I bring down the plus or minus. I bring down the square root. I go ahead and square b in my head when I do this. It causes me to make fewer negative errors. +1 times +1 is +1. In the formula every time, there's a -4 times a, which is 2, times c, which is -9, all over 2 times a. Now, you want to use your order of operations to simplify this, which means we start with what's inside the square root. Oops, that should be a -1, plus or minus the square root. The biggest mistake people make is right here. This is not a negative number. This is 1 plus -4 times 2 is -8. -8 times -9 is 72. And then we have 2 times 2, which is 4. This becomes -1 plus or minus the square root of 73 all over 4. Now, 73 is not a perfect square, so I go to my calculator and I put in the square root of 73, and I get 8.5. So I want to round that off to the nearest tenth. It's 8.54, so this is going to be -1 plus or minus 8.5 all over 4. Now, let's talk about what this plus or minus means. Remember when we solve using factoring, sometimes we get two answers. This is where the two answers come from. We have -1 plus 8.5 divided by 4, and we solve for that. So -1 plus 8.5, because the big fraction bar is a grouping symbol that groups the -1 and the 8.5 together. That gives me 7.5 divided by 4, and 7.5 divided by 4 becomes 1.875, which I'm going to round off to 1.9. Now, remember it was plus or minus. I did the plus. Now I need to do the minus. So it's -1 minus 8.5 divided by 4. I put that into my calculator, -1 minus 8.5. I hit enter because of the fraction bar being a grouping sign. That gives me negative 9.5 divided by 4. Negative 9.5 divided by 4 gives me negative 2.375, so I'm going to round that off to negative 2.4. You pause the video, you substitute into the quadratic formula, and then we'll check it. This was already in standard form, so you should have substituted this in as negative b, so it's negative in the front of the equation, comes from right here, and then a negative 5 plus or minus the square root. Remember I told you I go ahead and square my b before I substitute in so I don't make any negative errors. A negative 5 times a negative 5 is a positive 25, plus the negative 4 that's always there, times a, times c, all over 2 times a. Check your work. If you have that correct, you're ready to move on. The next step should be to simplify what's under your radical. I'm going to clean this up here. What's a negative times a negative? It becomes a positive. So this becomes a positive 5 plus or minus the square root of something divided by 10. You see if you can simplify what's inside the square root. Pause the video and try that one on your own. You should have brought over the 25. Negative 4 times 5 is negative 20. Negative 20 times negative 1 is positive 20. And then we simplify what's inside the square root, so that gives me 5 plus or minus the square root of 45 divided by 10. You see if you can use your calculator to find the square root of 45. Go ahead and pause the video and try that now. So then we go do 5 plus or minus. This gave me 6.708, so I'm going to round it off to 6.7, and that should be divided by 10. Now remember, this plus or minus tells you to split it up into two problems. 5 plus 6.7 divided by 10, and 5 minus 6.7 divided by 10. You see if you can solve those and get solutions for each. Remember, the big fraction bar groups those two together. You should have added 5 plus 6.7 and hit enter. That gives you 11.7. And then you divide by 10 and you get 1.17. For the other one, you should have done 5 minus 6.7 and hit enter. That gives you negative 1.7. And then if you divide by 10, it gives you negative 0.17, which you could have rounded these to 1.2 and negative 0.12, since it doesn't tell you what this should be rounded to. All right, this says use the quadratic formula to solve for x. It says round your answer to the nearest hundredth. So this time they're telling us what to round to. The nearest hundredth is like 2 decimal places. So if I had 4.378, the nearest hundredth would be right there. The 8 would tell me to round up, so that's 4.38. All right, this is already in standard form. So A is our 3, B is our invisible negative 1, and C is our negative 8. We're going to substitute in, it's negative B, so it's negative 1, plus or minus the square root. B squared is negative 1 times negative 1, which is positive 1, plus negative 4 times A times C, all over 2 times A. The next step is to clean up the outside. A negative and a negative make a positive, so that's 1 plus or minus the square root. 2 times 3 becomes 6. Now let's clean up what's in here. That becomes 1 plus. Negative 4 times 3 is negative 12. Negative 12 times negative 8, I'm going to do on my calculator. That gives me positive 96. So this becomes 1 plus or minus the square root of 97 divided by 6. 97 is not a perfect square, so we're going to need to use our calculator to estimate. We want the square root of 97, and that gives me 9.848. So if we round over to the side, that's 9.848. That's the nearest hundredth. We look to the right. The 8 says to round up, so this should become 9.85. So this is 1 plus or minus 9.85 divided by 6. Now I'm ready to split it up into two problems. 1 plus 9.85 divided by 6, and 1 minus 9.85 divided by 6. Don't forget to hit enter after you add and subtract because the big fraction bar acts like a grouping symbol. 1 plus 9.85 is 10.85. 10.85 divided by 6 gives me 1.808, which I'm going to round to the nearest hundredth as 1.81. For this one, I'm going to do 1 minus 9.85 and hit enter. That gives me negative 8.85. I'm going to divide by 6. That gives me negative 1.475. If I put that in, it's going to give me the wrong answer because it wants it rounded to the nearest hundredth. The 5 tells me to round the 7 up to an 8. You pause the video and try this one on your own. This is your A, your B, and your C because this is already in standard form. You should have substituted in. We've got a negative 6 plus or minus the square root. B squared gives me 36 plus negative 4 times A times C, all over 2 times A. Order of operations says to simplify what's inside the square root first. A negative times a negative becomes a positive, plus or minus the square root. I'm going to bring over the 36. Negative 4 times 3 is negative 12. Negative 12 times negative 2 is positive 24, divided by 6. We can't just cross those 6's out. Remember, these are being added and subtracted. They're not factors. This becomes 6 plus or minus 36 plus 24, which is 60, divided by 6. 60 is not a perfect square, so I'm going to find the square root of 60 and hit enter. That gives me 7.745, which rounds to 7.75 divided by 6. If you got that far, great. If not, see if you can go from here. See if you can now split this up into 2 problems. Pause the video, and then we'll go over it together. You should have split this up into 2. 6 plus 7.75 divided by 6, and 6 minus 7.75 divided by 6. Remember, the fraction bar is a grouping symbol, so that groups the 2 together on the top. 6 plus 7.75 is 13.75. Divided by 6 gives me, if I round correctly, 2.29. Then we do 6 minus 7.75 and hit enter. That gives me negative 1.75. Divided by 6 gives me negative 0.29. Now, these will not always be already in standard form. These need to be put into standard form first. So remember, standard form is ax squared plus bx plus c is equal to 0. So I notice that these are not equal to 0. So let's move the things that make this not equal to 0. We have 2x squared equals 5x plus 1. Let's subtract the 5x from each side. These are not like terms, so this gives me 2x squared minus 5x. I can't subtract those, but I wish I could. The 5x and the negative 5x cancel. I'm left with 1. Still not equal to 0. We're going to subtract 1 from each side. So this becomes 2x squared minus 5x minus 1 equals 0. This is now my A, my B, and my C. Had I used this as A, B, and C, all of my answers would be wrong because I would have been using a positive 5 instead of a negative 5 and a positive 1 instead of a negative 1. Now I'm ready to substitute in. There's a negative in the formula, and then the 5 is also a negative. Plus or minus the square root of b squared. Negative 5 times negative 5 is positive 25, plus negative 4 times A times C, all over 2 times A. A negative 5 becomes a positive 5, plus or minus the square root of 25, plus negative 4 times 2 is negative 8. Negative 8 times negative 1 is positive 8. And then 2 times 2 is 4. We're going to finish simplifying underneath the square root, underneath the radical. So this becomes 5 plus or minus the square root of 33 divided by 4. 33 is not a perfect square, so we're going to estimate that. The square root of 33 becomes 5.74. So that's 5 plus or minus 5.74 divided by 4. Now I'm ready to split that up into 2 problems. 5 plus 5.74 divided by 4, and 5 minus 5.74 divided by 4. 5 plus 5.74, hit enter, divide by 4, and we get 2.69. For this one, 5 minus 5.74, hit enter, divide by 4, and I get negative 0.185, which rounds to 1.9. You pause the video, and I want you to start just by getting this in standard form. Welcome back. You should have recognized that it was not equal to 0, so we're going to subtract 3 from each side. So we have 6x squared plus 4x minus 3 equals 0. This is now A, B, and C. All right, you pause the video and see if you can substitute into your quadratic formula, and then we'll check it together. You should have substituted in. This becomes negative 4 plus or minus the square root. B squared becomes 16 plus negative 4 times A times C, all over 2 times A. The negative 4 stays a negative this time because there's just one negative. We bring over the 16. Negative 4 times 6 is negative 24. Negative 24 times negative 3 becomes positive 72, all over 12. We're going to finish simplifying what's inside the radical. 16 plus 72 is 88, divided by 12. All right, if you got that far, I want you to try to pause the video now and see if you can finish. You'll need to find the square root of 88 and then divide it up into 2 problems. The square root of 88 should have become 9.38. And when you divide this up into 2 problems, it's negative 4 plus 9.38 divided by 12. And negative 4 minus 9.38 divided by 12. Negative 4 plus 9.38. Hit enter, divide by 12. Gives me 0.45 if I round correctly. Some of you are going to miss a lot of problems due to your rounding, so if you start getting these wrong, check your rounding. Negative 4 minus 9.38. Hit enter, divide by 12. I get negative 1.12 because it's negative 1.115 and the 5 tells me to round up. All right, the discriminant. The discriminant gives us some information about our number of possible solutions. The discriminant is just a small part of the quadratic formula. If you remember, the quadratic formula looks like this. The discriminant is what's underneath the radical. So if your discriminant is positive, if b squared plus negative 4ac is equal to a positive number, that means you're finding the square root of a positive number, and that's possible. That means you're going to have 2 solutions. If the discriminant is 0, b squared plus negative 4ac is equal to 0, that means what's under the square root is going to go away, which means there is nothing to add or subtract, which means there's just one solution. There's nothing that's going to change this to be 2 different solutions because the thing that we split it up into 2 with just disappears. If the discriminant is negative, then that means you have the square root of a negative number. We've learned that that's not possible, so there is no solution. No solution there. So let's try some. New topic, using the discriminant. You might want to write down that the discriminant is b squared plus negative 4ac. And if you did not write this down, you should do that in your notebook now. So let's pause the video and you should write down what's in this orange and pinkish table here. All right, so this is our A, this is our B, and this is our C. B squared is 16 plus negative 4 times A times C. We don't need to do all the rest. It's just telling me how many solutions I'm going to have. So this becomes 16 plus negative 4 times negative 4 is positive 16. 16 times negative 5 is negative 80. And then 16 plus negative 80 becomes negative 64, which means I would have the square root of a negative number, which means there would be no solutions, or you might write that as 0 solutions. For this one, it's already in standard form. So this is our A, our B, and our C. You pause the video and try this one on your own. You're just computing the discriminant and telling how many solutions you're going to have. All right, this should have become 49 plus -4 times -6 times -5. This becomes 49. -4 times -6 is positive 24 times -5 becomes -120. So this is 49 minus 120. And that gives me -71. So again, on this one, you'd be finding the square root of a negative number, which means there is no solutions there. And you're done. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 14. You should now complete Module 14 practice problem in ALEKS by continuing my path. Don't forget to use the explanation tab on the problems if you get stuck. You also should be reaching out to your teacher. Don't just sit on a mod forever and be stuck on it. Ask for help. When you've gotten help on all the practice problems and you've completed Mod 14, then you're ready to go to your assessments and select Quiz 14. Great job!